Okay, so today we are going to be having a brief discussion on how to do things like addition, subtraction, multiplication, and division with fractions. So let's start out and do some addition. So in a general scenario, if we have a over b plus c over d, how do we add these two fractions together? So what we would do is we would take a times d plus b times c over b times d. A lot of times we'll see this is something like cross multiplication, where we multiply numerator of our first, denominator of the second, and then denominator of first, numerator of second, and then put that all over the two denominators multiplied by each other. So how would we go about showing this? How do we know this is an accurate way to add these? In order to show that, all we need to do is take our a over b, and we really want to get our a over b and our c over d to have the same denominator. So what we do is we simply take and multiply our a over b by d over d. Since this value is going to be 1, this won't change the value of a over b, so we're free to do it. And likewise, we'll take our c over d and multiply it by b over b. Now, you'll have to watch ahead in the video to see exactly how we do multiplication of fractions, and as a result, this isn't insanely important. I just want everyone to kind of understand how we're getting to this, so it's not a magic equation kind of thing. So don't worry if this seems like something that you don't really understand what's going on, that's completely fine. I just think it's important to be able to go back and see where we're getting this equation. So we just take a d over db plus cb over bd. Now, if you think about it, we can write this out as 1 over bd times ad plus 1 over bd times cb. Okay, so with that being said, we can use the distributive property, kind of going in reverse, to write this out as 1 over bd ad plus bc. If you'll allow me to, I use the commutative principle kind of freely here. Sometimes I'll switch these two. So if ever it seems like I've done something that doesn't quite make sense, or if it seems like I've gone, it's typically just going to be I've applied the commutative or the associative principle without stating it. So just note that. So I have this, which I know I can rewrite as a b plus b c all divided by b d. And really, we can just get rid of these parentheses because this division symbol implies that you first do all the operations in the numerator and then all the operations in the denominator. So this really is our value here. So this is how you would get to it. Not that it's important in any sense, like I might make you prove it in class or that you'd have to prove it in this class, but I think it's important to know where these things come from. So with that being said, let's work through an example. 1 half plus 5 thirds. So all we do is we do 1 times 3, so 3, plus 2 times 5, so 10, over 2 times 3, so 6. And so this will get us 13 sixths. So this is an improper fraction, if you remember from the last video. So if we would like to convert this to a proper fraction, all we would do is take 6 and 13. How many times does 6 go into 13? 2 times. So 2 times 6 is 12. We subtract the 2, we get 1. And so from this, we get 13 sixths equals 2 and 1/6. So this will be the result of 1/2 plus 5/3. Okay. So, with that being said, what about subtraction? So, if I have two fractions of the form a over b minus c over d, what would I do to perform this operation? So this time, I'm not going to go through writing out the derivation again, because I think it's relatively pretty much the exact same type of derivation as the last one. Here we would just have a times d minus b times c, and all of that would be over b d. I will say this for the derivation. If you remember, we know through our last example that we did show a over b plus c over d equals a b plus b c over b d. So we've shown this. We should all be pretty confident that this is correct. So if you think about it, if I rewrite this as a b plus negative c over d, it seems reasonable that from the actual thing that we've pretty much proven, or at least shown very rigorously, we can write this, which is going to be the exact same as our original subtraction, as a d plus b times negative c over b d. And here we can use a combination of associative principle, and really it's going to be mostly just be the associative principle, to just rewrite this as a b, or my apologies, ad minus b c over b d. So here, while not as long as the previous, this pretty much proves this is the case through using really the thing we've shown previously. And really, this is going to be very similar to the last operation. So if we want to take 13 fourths and subtract 2 thirds, how do we go about doing that? All we would do is 3 times 13 is 39, minus 2 times 4 is 8. And this would be over 4 times 3, which is 12. We can simplify this to 31 over 12. Again, this is an improper fraction. How would we go about writing this as a mixed number? Well, we would take 12. Actually, we would take 12 divided by 31. So, let's see here. Actually, my apologies, 31 divided by 12. Yes, my apologies. So, in order to do this, we would get 2 times 12 equals 24. This would be 7. 11 minus 4 is 7. And so with that, we hit our end of this. This would be a decimal, so we stop here. And so we can write out 31 over 12 as 2 and 7/12. My apologies if I mixed up on which we are dividing by what. This would be 31 divided by 12. Okay, so with all that being said, we have subtracted two fractions, and so I think we can move on to multiplication and division. So for multiplication, really, this is going to be something fairly straightforward. So if I have a over b times c over d, if I were to multiply these together, all I do is multiply the numerators and then multiply the denominators. After we've gotten this, you might want to go back and watch some of the earlier derivations, because these earlier derivations or built upon using this. Okay, so with that being said, the division is very much the same kind of idea. We would have A over B divided by C over D. And what would that be equal to? Well, what we would do here is there's a number of ways we could look excuse me at this, but really, as far as the mechanics goes, we would write this out as A over B times D over C. And that would just give us A D over B C. Okay, so some examples of this. Let's say 1/8 times 7 halves. For this, we would get 7/16. Let's see if we were to do 3/4 divided by 2/8. What we would get is 3/4 times 8 halves, and that would give us 24/8. Now, this is a proper fraction, so we are free to stop there. This is an improper fraction, so how would we go about writing this as a mixed number? Let's see here. We would do 24 divided by 8. So how many times does 8 go into 24? 3 times. We stop there. And so this time, really what we would get is 3 and 0/8. Well, we don't really have to worry about that. So this would be equal to 3. Okay, with that being said, that covers all of the operations that we typically do with fractions. I will say one other thing. If we ever get to something like A over B cubed, or let's just say to the power of n, if we ever get something like this, let's see here. We know that if I have something like A over B times A over B, that I would just multiply the tops and multiply the bottoms. So if I have this written out where this keeps going, and so this would in all be n times, let me write out one last A over B, that we would multiply A by itself n times, and so we can write that as A to the n over B to the n. So really, this isn't too nasty. If we had something like 1/2 to the third, this would be the same as 1 to the third over 2 to the third, which equals 1/8. Okay, so hopefully now we all kind of understand how to do different operations on fractions. Please let me know if you have any questions after watching this video. Thank you very much.